From beyond the grave or beyond the goodnight command, the Kepler Space Telescope has done its first pretty impactful bit of science, and the discovery of some interesting physics that's happening in a Type 1a supernova called supernova 2018 OH, which more or less means that it was about the 400th supernova observed this year in 2018. So why is this supernova interesting? Well, in general, Type 1a supernovae are pretty interesting because we can standardize them, which means we can treat them as a standard candle, or they should explode with the same brightness no matter where they are in the universe. So if you measure how bright they are to us compared to how bright they are in the sky, you can work out properties regarding the universe itself. So they're interesting objects, but there are a few things we don't quite know about them. One thing is that there are two models as to how these supernovae might occur. In both models, they involve white dwarfs. So these are cores of stars like our Sun, which are in a binary system. So there's two objects. One system is the double degenerate system, where we have two white dwarfs orbiting around each other and eventually they collide and explode. The other system is something different. We have a white dwarf at the center, then a star not too dissimilar to our Sun orbiting around it, feeding material onto the white dwarf until it passes some specific mass, at which point we get a detonation occurring in the white dwarf. So both of these cases rely on one thing with white dwarfs, the Chandrasekhar mass. Once that mass limit is crossed, the thing explodes and we get our Type 1a supernova. Now, it's never been really clear which one of these two systems is responsible for the Type 1a supernova we use in cosmology. This is where the discovery of Kepler comes in handy. So Kepler seeing this supernova is useful for one particular reason. Kepler samples very finely in time. So most supernova surveys will take an image every couple of days, so you miss out a lot of information on that supernova. And particularly with Type 1a supernova, we're really interested in the first few days of the explosion. So if you just so happen to catch an explosion happening in one of Kepler's fields, you can measure every 30 minutes how bright that object is. And by doing that, they found this plot here. So generally you would expect a nice smooth rise going up for the light curve, or how bright this object looks. What they found for 2018 OH is that there's this kind of linear part, the straight part before the standard supernova rise. Now this might indicate a companion, and there's another bit of evidence that would also indicate a companion. So what these two bits of evidence support is that if you have a white dwarf and it explodes, the material jettisons out and eventually it'll reach the companion or donor star. That material will build up on the companion and create a very bright shock. Now, this bright shock will increase the brightness of the observed event depending on the angle of the system orientated to us. And it should make another prediction that the amount of blue light you receive from the supernova is much more in the early times of the explosion than what you would get slightly later on. So using Kepler, they found that it was brighter in the earlier stages, which fits with the first prediction of this model. And with the Pan-STARRS telescopes and DECCAM, they were able to get color information soon after the discovery of the supernova. And they found that in the early stages, it did have this blue excess in color. Now this might not rule out other models which the group analyzing this supernova looked into, but it is very strong indication that we may be dealing with what's called a shock interaction. This is pretty cool because it lets us learn about the system that exploded in the first place by fitting models to this object. And one of the best fitting models is a star a few times bigger than our Sun, about at a distance a third that of the distance between Mercury and our Sun. So this companion star was going around the white dwarf quite quickly. And this is probably, I think, the best case for explaining where this supernova in particular comes from. Now we'll need to find more of these shock interactions to understand fully how Type 1a supernova explode, But this is a first step towards understanding the physics of these very important objects. And I'm just glad Kepler, which was originally a planet hunting telescope, has been able to give us this awesome piece of information.